freezing time. So when I'll jump right into the lecture, there are three ways to explain it. First is what I call classically, that is getting inside the cycle time. I'll explain what that is. Then there's relativistically, and that's traveling at velocities near the speed of light. That's denoted by c, 186,000 miles a second. That's traveling around the Earth 7 times a second. And then the third time is quantum mechanically, exploiting what we call quantum effects. And Einstein even called this spooky action at a distance. So first, what do I mean by getting inside the cycle time? This is the heat cycle time. If you take a piece of ice, you heat it up, it melts, turns into a liquid, heat it up more, turns into water vapor. And if you take that water vapor and you cool it down, it turns into a liquid, and then finally turns back into ice. And this is what we mean by a cycle time. And so by freezing time classically, it's that you're doing something so fast that this cycle time looks like it's frozen. No pun intended. That is just standing still in time. So classically, getting inside the cycle time, things happen so fast that things tend to stop. At least they seem to stop. So how do you do it? High-speed computers. And fast processing time that you get with the new computers enable this freezing time. And those computers are getting faster and faster every single day. Now, Jane talked about Gordon Moore in one of her talks, and he is the founder, so to speak, of Intel, the chips. And what he discovered was something called Moore's Law, was that the speed of the chips increased by a factor of 2, which is exponentially about every 18 months. Now they're increasing in speed even faster because of quantum effects. But if you go back to the very first computer, the first mechanical computer was invented back in 1936, this thing was the first programmable and functional computer with 20,000 parts. And this was not electronics. This is one where you're cranking the wheel and all the parts of it interact. Do you think this thing was small? Well, it weighs about a ton, 1,000 kilograms. So it was not very small. And was it fast? It had a speed of what we call 1 floating operation point per second, 1 flop, and 64 words, not kilowords or anything like that, gigawords. And so it was adding 1,000, 2,000, 1 plus 1 plus 2. And so you can imagine how slow that this thing is. Compare that to the El Capitan supercomputer now in Lawrence Livermore National Laboratory, which, by the way, was the sister laboratory of Los Alamos National Laboratory, where I used to work. It was a big competitor of ours. But on the other hand, El Capitan, this past November, well, November a year ago actually, broke the world speed record at 1.7 exaflop, where an exaflop was a billion flops. So it's 1,000 million billion floating operation points per second. And this is not as fast as it can go. It's even exceeded this by over 2 exaflops. What about the iPhone? Well, your iPhone 14 can calculate things at about 11 trillion floating operation points per second. So this is still 1,000 million times slower than El Capitan, but yet what's in this iPhone, compare that back to that old computer I showed you in 1936. So even faster than that, though, is quantum computing. So you can see where Moore's Law has now been exceeded. And here's a picture of Google's Willow quantum computer. And the way this works is by using something called qubits. That is, it works with something called entangled states, which I'll explain in a couple of minutes. And what it does is it sets up calculations for every possible solution that is probable. And then when you're collapsing the wave function, is what it's called, it comes to that one solution. And it does so near instantaneously. I'll walk you through that because it has created some effects that nobody first believed when Einstein was around. Einstein said that he'd never believed quantum mechanics because of the spooky action at a distance, but we're seeing that changes in physics, that is, the science is continuing to evolve, have come up with some of these solutions that are just incredible. So, freezing time. Computer processing can occur faster than physical phenomena. That's